All right, let's jump right into this explainer and discover how graphing linear inequalities opens up a whole new zone of possibilities for our answers. If you've ever felt just a little constrained by a standard equation, the kind that only gives you a single exact number as a solution, you are going to absolutely love the shift we're making today. We are breaking free from plotting single targets, and instead, we're mapping out entire landscapes of truth. Here's our roadmap for today. We'll start with the zone of possibilities, look at the rules of the boundary, and then get into graphing slanted lines and the horizontal boundary. After that, it's your turn to graph, and we'll wrap it all up by talking about education fused with morality. Let's get to it. Part 1, the zone of possibilities, where we start expanding our answers. Think about a regular math equation like building a type fence. It's rigid, right? But an inequality, that's like claiming a whole open pasture. Instead of searching for one specific target, inequalities let us draw an expansive space where every possible correct answer lives. And what's interesting is how the HeroesmartAcademy curriculum connects this mathematical expansion to a central theological theme. In their Godly Learners series, they illustrate how these shaded regions in math mirror their view of God's generosity. By quoting Isaiah's call to stretch out the curtains of a tent, they show that just like making more room in a physical space, inequalities stretch out our solutions into a much broader, wider zone. Moving on to part 2, rules of the boundary and setting up our lines. Okay, before we can shade our pasture of answers, we've got to know exactly what kind of fence we are building to contain them. To graph any linear inequality, you really just need to follow these 3 reliable steps. Step 1, you just pretend the inequality symbol is a standard equal sign and find your intercepts to graph the line. Step 2, figure out if that line should be solid or dashed. And step 3, decide if the answers live above that line or below it. Honestly, it is that straightforward. So here is the absolutely crucial rule to remember. If your symbol has that little or equal to line underneath it, like less than or equal to or greater than or equal to, you draw a solid line. That means the boundary itself is actually part of the solution. But if it doesn't have that equal line, if it's strictly less than or greater than, your line has to be dashed. Think of a dashed line like an invisible force field. You can get infinitely close to it, but the boundary itself is entirely off limits. Next up, you just checked your symbol to find out where your zone of truth actually is. If y is greater than or equal to, you simply shade the entire area above your boundary line. If y is less than or equal to, you shade all the space below it. It really helps to just think of greater as the sky above and less as the ground below. All right, part 3, graphing slanted lines. Let's look at a couple of examples. Let's put these rules into practice. Take a look at this inequality right here. Y is greater than x minus 2. Now, notice right away there is no equal sign underneath that greater than symbol. That should instantly tell your brain, okay, strict boundary, we are definitely using a dashed line here. We start by grabbing our intercepts. When x is 0, y is negative 2. Boom, 0, negative 2 is our y-intercept. Then we find the x-intercept by making y 0, which gives us an x value of 2. We plot those 2 points, connect them with that dashed line we talked about, and then, because it is greater than, we take our pencils and boldly shade that entire expansive space above the line. Literally every single point in that shaded area makes this inequality completely true. Let's step it up for our second example and see what happens when we throw a less than or equal to symbol into the mix. The equation here is y is less than or equal to negative 2x plus 5. Just like before, we hunt down our points. When x is 0, y is 5, so y-intercept at 0, 5. When y is 0, we solve for x and land on exactly 2.5 for our x-intercept. We plot them, but this time we use a solid, heavy line to connect them because of that equal to piece of the symbol. And finally, since it's less than, we shade the whole zone below the line. See? You are totally mastering this. Section 4. The horizontal boundary. This is for when things go flat. So sometimes your boundary line isn't slanted at all. Check out this inequality, y is greater than or equal to 3. Notice anything missing? The x is completely gone. And that kind of changes how we handle our intercepts, because there is literally no x to plug a 0 into. Because this line stays totally flat at y equals 3, it just runs perfectly parallel to the x-axis. It shoots off forever to the left, forever to the right, and it will never, ever cross the x-axis. This creates a really unique scenario where absolutely no x-intercept exists. We actually call this the horizontal line anomaly. To break down this anomaly, Our y-intercept is simply 0, 3. Our x-intercept is, well, none. So we just draw a solid horizontal line straight through the number 3 on the y-axis. It's solid because of the equal to line in our symbol, remember? And since y is greater than 3, we just shade all the mathematical possibilities stretching out into the sky above it. Okay, part 5, your turn to graph. Homework time! Now it's your turn to map out these zones of truth. Go ahead and pause this explainer right here so you can jot down these 5 inequalities for your practice. Just remember your basic rules. Check if the line should be solid or dashed, find your intercepts, and ask yourself, am I shading the sky above or the ground below? You've totally got the tools you need to crush this. And finally, Section 6, Education Fused with Morality, looking at the bigger picture. As we wrap up the math side of things, the source material actually connects these academic steps to a much broader life lesson. The core philosophy of this curriculum argues that, honestly, there is very little point in being highly educated if it isn't paired with morality. They suggest that education gives you the tools to build things, sure, but a moral compass gives you the blueprint to build something good. In their view, if someone uses their intellect to make harmful choices, that education actually turns into a destructive force. Knowledge has to be paired with character. Drawing right from biblical texts, the curriculum notes that true peace of mind is promised to those who keep their focus spiritual. The authors are highlighting that as learners engage with this combined approach, they aren't just, mindlessly plotting lines on a graph. They're meant to experience a grounding peace, training the mind and the heart at the exact same time. So as you go forward today, as you shade your graphs and make your daily choices, how will you ensure your own education is consistently guided by a strong moral compass? You know the boundaries between solid right and dashed wrong, and you know exactly where the good fruit grows. What kind of life will you build in your zone of truth? Keep stretching out your tent, keep learning, and I'll catch you in the next explainer.